Hello everybody. Today we are trying to look inside of the famous binocular head of a Nikon Smz-u. So this head is, we could say, kind of art thing. It's not ordinary a lot of glass, but it more likely thing made with a big passion. So it consists of three main parts. First part is the objectives that project our located in infinity view into a finite position, located to the outer edge of eyepiece tubes. Second thing is erecting prisms. Those prisms have five sides. I forgot their name as usual, but the main thing is those prisms are very big, the biggest ones I ever seen amongst other heads. They're connected with some plastic bolts and glued with some, you could say, hard glue here. And after that, after second block that was erecting a view, it means it turns up to down and left to right. Its name's erecting. And by the way, it turns a view, moves it to 45 degrees. It we could say leans at 45 degrees angle. And after that, we have huge displacement prisms. They're here. They made let us move eyepiece position down for 5 centimeters here, and by the way, they let to keep a parallel view of those eyepiece tubes, changing their widths. So all the time eyepiece tubes are parallel, while eye distance is changed. And as you can see, those parts, sides are not coated as they should, because they are making a total internal reflections. So no coatings here, but we have very cool coating on exit prisms. Those prisms are still not cleaned properly. And on our erecting prisms, they have very cool coating too, but we can't see it through the lenses. It's not that easily seen. So it is our Nikon Smz-u binocular head, and this head, while being very nice made and having pretty clean view, had a lot of internal surfaces covered with a lot of we could say dust or kind of vaporized grease layers. If you put those prisms close to the strong source of light, you can see that those prisms are getting white because internal reflection is getting obstructions as a vaporized layer. It turns all reflection not to be totally internal. When we move a source light close to rectangle prism, we can see that all path is lit with a bright we could even say kind of milky cover, and thus the contrast is significantly decreased in this case. So those prisms need to be removed. We need to clean them on all sides, and after that we need to get it back with our adjustment and put some kind of glue back. So wait a moment, I will show you how the coating on erecting prisms looks like. Wait a moment. So I just removed those eyepiece displacing long prisms. We can see internal coating on our erecting 5-side prisms. We can also see this kind of glue here. It left prism are located on little parts, so there is easy way for dust to get under it, but to clean it we need to remove those prisms totally. And by the way, you can see how those displacing prisms look like. Wait a moment here. Here are displacement prisms. They got very cool and strong coating. It's pretty clean here, but still prisms are covered with a lot of vapored things, like vapored or just very fine dust, I would say, not vaporing things. We can see a lot of internal obstructions here. This device, these parts are made with very high quality. We can see 4 bolts that holds eyepiece parts. We can see our internal mist of fogginess here. It's easily seen. Oh, yes. And we can see the part of plates with which this displacement prism is attached to the erecting prism frame. So thank you for watching. Now it's time to make cleaning and adjustment. So I'll show you how it went when it is ready. Okay, thank you very much for watching.